Let's take some slightly more challenging problems to do. So what does the question say? It says find the value of each variable and the measure of each labeled angle. In other words, it wants you to find each variable in the problem, and in this case it wants you to find x and y, and then it wants you to find the measure of each labeled angle. That means it wants you to find this angle over here, this angle over here, and this angle over here. And we're going to use a number of methods of doing this. Number one, we're going to use the fact that vertical angles are equal to solve for x. And then we're also going to use the fact that these two angles over here are a linear pair. In other words, they are adjacent angles that sum up to 180 degrees. So we're going to use both of those theorems in order to solve for x and y and find the measure of the angles. So here we go. Let's set these two vertical angles equal to each other. So in other words, we know that 3x plus 8 is equal to 5x minus 20. Okay, subtracting 3x from both sides of our equation, I get 8 is equal to 2x minus 20. When I add 20 to both sides of my equation, I get 2x is equal to 28. Dividing both sides of the equation by 2 gives me x is equal to 14. So it looks like that's the answer for x. But right now we could easily check to make sure that these vertical angles are equal, which we're going to do, but let's first find y. How do we find y? Well, I know that these two angles, this 3x plus 8 and this 5x plus 4y, these are a linear pair, which means their sum should be equal to 180. So let's set 3x plus 8 plus 5x plus 4y equal to 180 because they are a linear pair. Well, I know what x is. X is 14. So I have 3 times 14 plus 8 plus 5 times 14 plus 4y is equal to 180. So now let's do the math. So 3 times 14, which is 42. So 42 plus 8 plus 5 times 14, which is 70, plus 4y is equal to 180. So 42 plus 70. So I have 42 plus 70, which is 112, plus 8. So I have 50 plus 70 plus 4y is equal to 180. 70 plus 50 is 120. So I have 120 plus 4y is equal to 180. I subtract 120 from both sides of my equation, and what I get is 4y is equal to 60. Dividing both sides of your equation by 4 gives you y is equal to 15. So it looks like I have both of the answers, but I also want to find the measures of each of the angles. So let's see what the first one is going to be. So I'm looking at 3x plus 8. So 3 times 14 plus 8. Let's see what that is. So 3 times 14 we said before was 42, and 42 plus 8 is 50. So this angle here is 50 degrees. And that means that 5x minus 20, when I substitute 14 for x, should also be 20. It better be. Let's take a look. So 5 times 14 minus 20. Well, 5 times 14 is 70, right? And 70 minus 20 is equal to 50, right? So 70 minus 20 is equal to 50. So this angle is also 50. That's a good sign. What should this angle be? If my math is correct, if x equals 14 and y is equal to 15, the measure of this angle should be 50 supplement, which is 130. Let's take a look. So is 5 times 14 plus 4 times 15, is that equal to 130, right? So I I'm saying this needs to be 130 degrees. Let's see. So again, 5 times 14 is 70, plus 4 times 15 is 60. Is this equal to 130? Well, yes, 70 plus 60 is equal to 130. 130 is equal to 130. So my answers of x equals 14, y is equal to 15 is correct. And here are the values of the angles, 50, 50, and 130. Why don't you try to do question number 30, put your player on pause, and then when you're done, hit play again, and I'll catch you on the other side. Okay, so let's take a look at this problem. So first, let's erase what we have here. Let's clearing from page so we have plenty of space to work with. Okay, so the question is, how do we find the measure of each angle? Now, it is true that 2x is equal to y minus x. But how does that help me? I have one equation with two variables. That doesn't work. I have 2x plus y plus x is equal to 180 because these are supplementary angles. But that doesn't help me either because, again, I have one equation with two variables. But let's take a look at these two angles. In other words, let's take a look at y plus x and its supplement. In other words, I know that y plus x plus y minus x is equal to 180. The reason this is nice is because I have a positive x over here and I have a negative x over here, which cancel each other out. So in other words, I've got 2y is equal to 180. If 2y is equal to 180, when I divide both sides of my equation by 2, I get y is equal to 90. Now we're not saying that an angle is 90, we're just saying that y is equal to 90. Remember, I need to find the value of both variables. But this is fine because now I can set up the vertical angle relationship. I know that 2x is equal to y minus x. Y is 90 degrees, so I've got 2x is equal to 90 minus x. When I add x to both sides of my equation, I get 3x is equal to 90, and dividing both sides of your equation by 3 leaves you with x is equal to 30. So it looks like I've got both of my variables, y is equal to 90, x is equal to 30. But we need to find the measure of the angles. So let's take a look. Let's find the measure of this angle first. Well, if x is equal to 30, 2 times x is 2 times 30, which is equal to 60 degrees. Let's take a look and see if this angle is also 60 degrees. Well, y is equal to 90, x is equal to 30, and 90 minus 30 is 60 degrees, so that works. What should the measure of this angle be? Well, it should be 60's complement. In other words, what is 180 minus 60? Should be equal to 120. Let's see if it is. This angle here is represented by y plus x. If y is equal to 90 and x is equal to 30, 90 plus 30 is equal to 120, so that definitely works. Let's learn a couple of other theorems which are going to be important. So let's take a look at these two intersecting lines which form vertical angles. Given AB and CD intersect at E. Very nice. They intersect at E, and angle DEB is 73 degrees. So the first thing I do is I mark this as 73 degrees. Find the measure of DEA. In other words, I want you to find the measure of this angle. CEB, they want you to find the measure of this angle. And AEC, which is this angle over here. So let's see. If DEB is 73 degrees and I have these two intersecting lines, I know that AED plus DEB is equal to 180. In other words, I know that angles AED plus angle DEB are equal to 180. They are angles that form a straight line. They're a linear pair, which means their sum is equal to 180. Well, if DEB is equal to 73 degrees, that means that angle AED plus 73 is equal to 180. So what I'm going to do is I'm simply going to subtract 73 from both sides of my equation, which means angle AED is equal to 180 minus 73, which is equal to 107. So angle AED is 107. Because angle AED and angle CED are vertical angles, and vertical angles are equal, this must also be 107. So AED, or DEA, is equal to 107. We also know that CEB, or BEC, is equal to 107. And we know that DEB is 73, and DEB and AEC are vertical angles. These two are vertical angles, so that means that AEC must also be 73 degrees. Well, let's see what we got. It looks like DEB is 73, and it is supplementary to AED. And DEB is also supplementary to CEB. So therefore, what do we know? Well, we know that if two angles are supplements of the same angles, then those two angles must be congruent. In other words, these two angles, angle AED and angle CEB, are supplementary to the same angle, namely angle DEB. They're both supplementary to 73 degrees. If each of these are supplementary to the same angle, then those two angles must be congruent. So let's take this down in our theorems and definitions. Put your player on pause, take this down before you go on to the next slide. Okay, let's take a look at something else. Look at what I have here. I have two right angles. In other words, I have angle angle EIF, plus angle FIG, which are equal to 90 degrees. You know that because they're giving you this square here, right? So angle EIF, that doesn't look like angle angle EIF plus angle FIG are equal to 90 degrees. I also know, let's erase this, I also know that angle HIG, plus angle FIG, are also equal to 90 degrees. You can see that right over here. In other words, here's FIG and here's angle HIG right over there. And they are also equal to 90 degrees. You can see that because they give you this angle, that square. Let's draw this a little more nicely. Okay, so we know that HIG, which is right over here, which is this angle right over here, and angle FIG, which is this angle right over here, when added together, give me this right angle. So both of these things are true. If that's the case, let's see what I've got. I've got HIG plus FIG is equal to 90 degrees. So wherever I see 90 degrees here, I might as well just substitute that with HIG plus FIG, right? These two are exactly the same thing. So I could say that angle angle EIF, let me undo that, angle EIF plus angle FIG is equal to angle HIG plus angle FIG. Both of them are equal to 90 degrees, which means these two pairs of angles, this pair and this pair, must be congruent to each other. Well, suppose I subtract, let me subtract in another color, angle FIG from both sides of my equation, because all this is an equation right there. Well, that means that these two angles are gone, which means angle EIF is congruent to angle HIG. Angle EIF, which is this angle over here, which I will color in purple, is equal to angle HIG, which I will color in red. So what does that tell us? Very simply, that tells us that if two angles are complements of the same angle, or of congruent angles, then the two angles are congruent. Both EIG and HIG are complements of angle FIG. And if that's the case, that means that EIF plus HIG must be congruent to each other. Put the player on pause, and please take this down in your notes before you continue. Okay, let's see what our next theorem is. What have we learned? Let's see. I have line segment CD that forms right angles. These two angles are right angles. So if these two are right angles, well, that means that each of them are 90 degrees. So this is 90 degrees and this is 90 degrees. And we know that 90 is equal to 90. So we could say that what? We can say that all right angles are congruent. Let's put your player on pause and take this down in the theorems and definitions section of your binder. Okay, let's take one more. Given line segment ADB, this is the straight line right over here. If it's a straight line, that means we've got 180 degrees. So this whole thing is equal to, as you guessed it, 180 degrees. And CD intersects AB. So CD intersects AB. And they're telling us that CDA is congruent to CDB. So what I'm going to do is I'm going to actually indicate that. So what I want to do is I want to show that CDA and CDB are congruent. So I'll do this. There's an arc and there's an arc. That's how we show that two angles are congruent to each other. So they're asking me to find the measure of each angle. So if these two are equal to each other, let's use a variable x to represent these angles. So CDA is x and CDB is x. If this is a straight line, which it says right over here, straight line CDB, that means that if I add x plus x, that is equal to 180 degrees. Or 2x is equal to 180 degrees. Well, if that's the case, when you divide both sides by x, x is equal to 90. So what does that mean? Well, very simply, that means if I have two angles that are equal to each other and that are supplementary, then it must be true that if two angles are congruent and supplementary, then each is a right angle. Let's put your player on pause and take down this theorem, theorem 2-5, in your notes. Okay. And that is it for this lesson. I hope this was helpful.